Good evening, everyone. Welcome to York Observatory's Teletube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. We are broadcasting live from the Ellen I. Carswell Observatory located at York University in Toronto, Ontario, Canada. Teletube broadcasts every Wednesday night at 7:30 p.m. local Toronto time. For any questions or comments you have about our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can also connect with us on Twitter or Instagram with the handle at York Observatory and Facebook at Ellen I. Carswell Observe. I'm Arfa, and I'll be one of your hosts this evening, along with Noah, Shannon, and Matt. And tonight, we've got a great presentation about the planet Neptune. Before we get started with our main show, we want to give you a little update on what you can see this coming week. Tonight, right after sunset, the very bright planet Venus will gleam. Jupiter and Saturn will also be visible at the lower right of the duo. Our topic of today, Neptune, will also be visible later at night until sunrise in case you're planning to stay up. The Andromeda galaxy will also be visible right after the sunset, along with some other bright stars in the sky like Vega, Deneb, and Arcturus. Tonight, the moon is in a waning crescent phase. Before we get started with the presentation, I'll hand the screen share over to Obada and Laura to show us some live images from the 1-meter telescope. So I guess we are looking at Venus right now, right?
I believe so. Yeah, it looks like Venus is up and visible.
It's
Awesome.
actually amazing. We've had so many cloudy days recently that it's nice to actually have some live imaging.
Yeah, I remember those days. But yeah, like Venus looks so bright, and we can actually see the color for the Venus as well. And it's in the gibbous phase right now, I guess.
Does anyone want to start off with some Venus facts?
Sure, I can go ahead. So everyone knows that Venus is actually called our the Earth's evil twin sister because it's believed once it was similar or like similar condition for Earth. But if Earth's greenhouse effects continue getting worse, we might end up like being Venus. So that's why it's called the evil twin sister. And also one more thing, also it's like Mercury, despite it's closer to the sun, but Venus is much hotter than the planet Mercury. And I guess it's one of the hottest planet in our solar system.
Yeah, very true. Arfa, yes, so Mercury, as you mentioned, is the closest to the sun. So you would assume that it would be the hottest planet, but it's not. As you said, that Venus is the hottest planet in our solar system. And the reason for that is actually because of its atmosphere. So its atmosphere actually does a greenhouse gas effect. So as you guys know about climate change, and the more greenhouse gases we have in our atmosphere, it keeps the heat in. It's kind of like a shell. So Venus has this really strong greenhouse gas effect, which causes all of the all of the gases to stay in, all the heat to stay in. So that's why it's the hottest planet.
And if you want to be specific with how hot it is, it's actually around 475 degrees Celsius. So absolutely insanely hot temperatures, unimaginable for us here on Earth. But apparently, it's actually past the melting point of lead. So it's that hot. And the atmosphere too, it also creates a really enormous pressure. And the pressure is actually 90 times the pressure that we feel here. So crazy weather, atmosphere, all that sort of stuff, temperature that you would find on Mars. And as Arfa mentioned, it was quite like Earth in the past. So potentially what Earth might be like one day, and hopefully not, and at least hopefully not anytime soon, but it may eventually reach that point.
Yes,
Well,
definitely. We don't want Earth to be like Venus, where we would be, I don't know, melted away. But that's some really great facts. I got another one. So it's Venus takes longer to rotate once on its axis than to complete one whole orbit. So the year is shorter than the day. So that's some really crazy fact. And that's not the only thing that's weird. It's this is like, unlike other planets, Venus spins clockwise on its own axis. So unlike Earth, imagine having sunsets and sunrise at the opposite ends of the compass. So that's something that's quite weird about Venus. Shannon?
yeah, so that's actually really interesting. And as you guys talk about how hot it is, Venus is actually named after the goddess of love. So that kind of makes sense. And as you guys said, like Venus being the twin sister of Earth, the evil sister, it actually has a very similar gravitational acceleration to Earth. So Venus has a gravitational acceleration of 8.8 meters per second squared compared to what it is on Earth, which is 9.8 meters per second squared.
I also don't know if any of you heard, and if you did, I just a refresher is a few months ago, I think it was, can't remember exactly when, believe it was 2020, when they found a gas in the atmosphere that could have pointed towards potentially life high up in the atmosphere of Venus. So that's just a super cool thing that I'm sure is still being looked into really in depth. You were mentioning same thing about how it's like Earth's twin sister, or evil sister. And something cool is that you mentioned that it rotates in the opposite direction to Earth, but that actually also means that the sunrise and sunsets are in the opposite direction. So instead of rising in the east and setting in the west, it would actually be the exact opposite. So that's just a fun fact about Venus as well.
Another thing I would like to mention, sorry about that, but taking into account what Arfa mentioned about Venus being the evil twin of Earth, we have to take into account that that's not only the the weather. It's not, or how hot it is not the only reason why we call it its twin, but rather than its size is really similar to Earth. And another fun fact I could say related to Venus is that unlike Earth, we could say that it spins clockwise on its axis. And the reason for this is because it's actually upside down. So yeah, that's pretty amazing. So it's Earth's evil twin because it spins upside down. It spins clockwise, I'd say. It is upside down, and it is also, well, really similar to Earth in size and density.
Yeah, that's actually pretty cool. Another fact is that Venus is actually the second brightest natural object besides the moon in our night sky, which means, in my opinion, I think Venus is a little bit easier to see. I'm so glad today we were able to see it. So the reason why it's so shiny and reflective and it's easier to see because it's so bright is because of the sulfuric acid in the clouds of Venus's atmosphere. As I said, it has a really strong atmosphere, and it's the only other planet besides Earth that has a very prominent atmosphere in our solar system. So the brightness actually makes it pretty visible even during the day. If it's clear, you don't have too much city pollution, like air pollution, you can see it up north. And yeah, some people mistake it to be a star or the moon, but sometimes it's Venus.
I do need to mention when we're looking at Venus, the fact that Professor Hyde told us last time that in fact Venus can appear so bright that a pilot on Air Canada mistakenly thought it was another plane when it was actually Venus.
Oh, wow. Yeah, so yeah, because Venus is so easy to spot with like the naked eye sometimes. And I think because we live in the city, we kind of not see it as much. It's actually impossible to say who discovered Venus, but over time, scientists have been able to measure Venus's motions, such as there is a rare transit of Venus when the planet appears from Earth to cross in front of the sun, which is really cool.
All right.
Go ahead.
Sorry about that. So we will be coming back to the live viewing soon. So I'll let Noah tell us more about Neptune. Just one second. And there we go. All right.
All right, thank you, Arfa. So as mentioned, we are discussing the 8th planet in our solar system tonight, and to be honest, probably one of the ones that's least talked about, Neptune. And Neptune is named for the Roman god of the sea. It's the farthest planet in our solar system, around 4.5 billion kilometers from the sun, and because of this, it's the only planet that cannot be seen without optical aid. So you may be wondering, how was Neptune discovered, especially such a long time ago, from that far away? Well, it was actually first identified not by viewing it, but by predictions and calculations. Urbain Le Verrier predicted Neptune's location and mass, as he was aware that there was some massive body disrupting Uranus's orbit via gravity. Once these predictions were made, scientists began looking for the planet, and Johann Gottfried Galle identified it through a telescope on September 23rd, 1846, making Neptune the second planet to be discovered by a telescope. Since Neptune's initial discovery, many findings have been made about Neptune. Say, the length of 1 year on Neptune, approximately 165 Earth years, or the gravity on Neptune, 10% greater than Earth's at its surface. As you can probably tell from the immense length of 1 Neptunian year, only one of which has passed since Neptune's discovery, it is very far away, at 30 astronomical units from the sun. This means that at the speed of light, the speed limit of the universe, it takes 4 hours to reach Neptune from the sun. It also means that everything is a lot more well lit here on Earth than it is on Neptune, 900 times brighter to be exact. Scientists have also delved into Neptune's formation. It likely formed with the solar system 4.5 billion years ago from gas, dust, and gravity. However, it probably originated a lot closer to the sun than it is now, then traveled to the far reaches of our solar system 500 million years later. There's a theory that explains this, the Nice method, Nice is in the French city, which states that Neptune and a few other planets were pushed out of their close, ideal, stable orbits around the sun by bodies known as planetesimals, leading to their current positions today. Another major discovery about Neptune has been its moons. There are 14 known satellites of Neptune to date. And, as is set by the International Astronomical Union, all moons must actually be named for other mythological sea gods and nymphs. Something I found really interesting was that on October 10th, 1846, only 17 days after Galle's discovery of Neptune, English astronomer William Lassell discovered Neptune's largest and most famous moon, Triton, also known as Neptune's only moon of a spherical shape. It's unusual in that it orbits Neptune opposite to Neptune's rotation, meaning that it has a retrograde orbit. Due to this, scientists actually believe that it may have been an object in space, such as a dwarf planet, that was drawn into Neptune's orbit at one period in time, and that it's currently spiraling towards Neptune. There are many, many more fun facts about Triton that I could talk about, but some key points are that it is similar in size to our own moon, the Earth's moon. It is extremely cold at negative 240 degrees Celsius, and it has a lot of unique features, including active nitrogen-releasing volcanoes, an atmosphere, and seasons. There may even be an ocean composed of water existing below Triton's surface. So, of all places, it's very fitting for the water theme of the planet of Neptune and its moons. 103 years after the discoveries of Neptune and Triton, Gerard Kuiper, yes, of whom the Kuiper Belt was named after, discovered Neptune's second moon in 1949. Nereid is the third largest of Neptune's moons and has a really high eccentricity, meaning that its orbit is very far from being circular. And its eccentricity is greater than any other discovered moon so far. Then the Voyager 2 mission revealed 6 more moons. There's Proteus, the second largest Neptunian moon, and a non-spherical moon that's mass is likely just smaller than the required mass for it to be spherical. Galatea, Larissa, Despina, Thalassa, and Naiad. After these findings, Naiad was actually not seen for decades until it was rediscovered by Hubble imagery and analysis only a few years ago. This may be because of a glare from Neptune, which is millions of times brighter than Naiad itself. 5 more moons were discovered between 2002 and 2003, again from telescopes back on Earth. These are Laomedeia, Halimede, Sao, Neso, and Samathe. Before the last one yet, Hippocamp was discovered in 2013 by Mark Showalter. Showalter was, he used Hubble data from the 2000s and analyzed it. And since then, analysis has suggested that Hippocamp could actually have once been a part of the other moon, Proteus. These 14 moons are suspected to actually maintain the rings around Neptune, which you'll learn about a little later. And the 6th ring, the outermost ring, is predicted to be potentially controlled by Galatea in specific. It is thought that it maintains the separation of arcs of icy matter in this ring, preventing them from joining into a complete ring. So now that you know more about Neptune's and its moons, we'll delve deeper into its features. Take it away, Shannon.
Well, thank you, Noah. So I'm going to be talking about Neptune's size and orbit. Neptune is such an underrated planet. We all seem to forget about this blue ice giant planet. Neptune is a big planet. It has a radius of 24,622 kilometers. Neptune is so much larger than Earth. It's 4 times wider than that of Earth. An example to help everyone understand the sizing of these planets a little bit better. If Earth was the size of a nickel, then Neptune would be as big as a basketball. As Noah mentioned, Neptune is very far away from the sun. On average, it is 4.5 billion kilometers away from the sun. In other words, Neptune is 30 astronomical units away from the sun. Astronomical units, also known as AU, is the distance from the sun to the Earth. As Noah said, this distance is so far that it can take sunlight around 4 hours to travel from the sun to Neptune. The time it takes for Neptune to rotate or spin once is about 16 hours. A year in Neptunian time, which means a complete orbit around the sun, is about 165 Earth years. That's 60,190 Earth days. So most of the time, we assume that the farthest significant object is the dwarf planet Pluto, right? Actually, not all the time. Sometimes Neptune can be even farther from the sun than Pluto. So let me explain why. Pluto has an orbit that is highly eccentric and oval shaped, which means that for a 20-year period, every 248 Earth years, the orbit causes Pluto to be brought inside of Neptune's orbit. As a result, Neptune is therefore farther away from the sun than that of Pluto. Cool, right? The amazing event happened most recently from 1979 to 1999. Now you may wonder, well, if Pluto is in Neptune's orbit, will it not crash into Neptune? Surprisingly, no. Pluto will never crash into Neptune, since for every 3 laps that Neptune takes, Pluto takes 2. The pattern that each planet takes prevents them from coming even close to each other. The axis of rotation of Neptune is tilted 28 degrees with respect to the plane of Neptune's orbit around the sun. This is very similar to the axial tilts of Mars and Earth. Earth and Mars, as you guys may know, experience seasons, which means that because of the similar axial tilt, Neptune also experiences seasons. In contrast to seasons on Earth, since Neptune has a very long year, each season lasts for over 40 years. Imagine if Earth had seasons that long. I would not be able to handle 40-year-long Canadian winters. Other than Uranus, Neptune is one of the two ice giants in our solar system. Over 80% of Neptune's mass is made up of a hot and dense fluid made up of ice materials such as water, methane, and ammonia. The fluid is above a small rocky core. Out of all the giant planets in our solar system, Neptune is actually the densest. Some scientists believe that Neptune has an ocean of hot water under its cold clouds. The reason why the hot water does not boil and vaporize immediately is because the high pressure on Neptune keeps the water locked in a liquid state. Now, Neptune has a very strange magnetosphere. Its magnetic field's main axis is tipped over by 47 degrees when compared to its own rotation axis. In contrast to Uranus, which has a magnetic axis that is tilted about 60 degrees from the axis of rotation, Neptune has a magnetosphere that varies during each rotation because of its misalignment. However, Neptune's magnetic field is very powerful. It is 27 times more powerful than that of Earth. Neptune does not actually have a solid surface. Instead, its atmosphere, which is made up mostly of hydrogen and helium with a small percentage of methane, extends to very great depths on Neptune, which eventually begins to merge into the water and other melted ices over a solid core that is heavier and has a mass like that of Earth. Uranus is Neptune's neighbor and is a stunning blue-green color that is due to an atmospheric methane. In contrast, Neptune is much more vivid. It is such a bright blue planet. Methane is responsible for giving the planet its color. This is since the gas has a composition that absorbs red light and reflects blue light outward. However, it is unknown as to how Neptune can be so bright. There must be a component in its atmosphere that is a reason why Neptune has such an intense color. Maybe in the future, we'll get to know why. So you guys may all know, but Jupiter is known for its storms. But did you guys know that Neptune is actually the windiest planet in the solar system? Yes, even though Neptune is far away from the sun and receives a very low energy input from the sun, Neptune can have winds which are actually 3 times stronger than that of Jupiter's and 9 times stronger than that of Earth's. Neptune's powerful winds can cause clouds of frozen methane to travel across the planet at speeds of more than 2,000 kilometers per hour. In contrast, Earth's winds seem so weak. Our planet's most powerful winds only reach up to 400 kilometers per hour. That's only 20% of Neptune's wind power. Amazingly, in 1989, it was discovered that Neptune has a large oval-shaped storm in its southern hemisphere, and it was named the Great Dark Spot. The Great Dark Spot is large enough to contain the entire Earth. More recently, it was discovered that the storm has disappeared, but new ones have begun to appear all over the planet. Now, Neptune has rings. Yes, Neptune has at least 5 main rings and 4 prominent ring arcs. The main rings are named Gal, Levier, Lassell, Argo, and Adams, and they go in order from the one closest to the planet to the one that is the farthest. These rings are the main rings, but they're thought to be actually relatively young and short-lived. So, of course, Neptune's ring system does not just include its rings. No, it's not just its rings. Surprising, right? It also includes strange clumps of dust called arcs. There are 4 prominent arcs which are named Liberty, Equality, Fraternity, and Courage, which are in Adams, the most outer ring. These rings, as I mentioned, are strange because if they use the laws of motion, we would predict that the dust would spread out evenly instead of clumping together. Scientists now think that the moon that it is inward to Adams, gravitational effects is a reason as to why the arcs are stabilized. Now, on to you, Matt.
Thank you, Shannon, for letting us know a little bit more about Neptune and its moons and its rings as well. And as it was mentioned before, Neptune was officially discovered in 1846, I'm sorry, but we had to wait over 100 years in order to finally have a human-made object that could reach its orbit. If you weren't able to watch our Jupiter's Teletube, I encourage you to do so, since we didn't only mention all about my favorite planet, which is Jupiter, of course, but all the missions that had the opportunity to cross its orbit, as well as the discoveries they made. One of these missions was the Pioneer 10, which was actually the first human-made mission to fly beyond Mars, the asteroid belt, Jupiter, and yes, you guessed it, Neptune. In 1983, the Pioneer 10 mission was the first object to finally reach and cross the orbit of Neptune. Later on, several missions, including both Voyagers 1 and 2, which I'll mention in a little bit more of detail later on, also crossed the orbit of Neptune, as well as Pioneer 11, which crossed the orbit of Neptune 7 years later on February 23rd, 1990. Sadly, I do need to mention that Pioneer 10, Pioneer 11, as well as the Voyager 1 mission were only passing by the orbit of Neptune. Therefore, neither have the option to study it in depth or explore the Neptunian system. But don't lose hope, because one mission did achieve to do this, Voyager 2. Now, the fact that the Voyager 2 probe managed to get to the Neptunian system wasn't something that was actually planned from the start. So we could say that so far, the only mission that has been to Neptune was a pure coincidence. But a good one, of course, because it allowed us to explore and discover a lot of interesting data about Neptune and Uranus. In January 1981, a decision was made in order to correct the trajectory of the Voyager 2 mission and send the spacecraft to Uranus and Neptune later in the decade. Following the Uranus encounter, the spacecraft performed a single mid-course correction on February 14, 1986, which was the largest ever made by Voyager 2 in order to set it on a precise course to Neptune. The flyby of Neptune concluded Voyager's 2 planetary encounters, which spanned an amazing 12 years in deep space, virtually accomplishing the originally planned grand tour of the solar system. But we all know that the Voyagers didn't end their missions there. But you'll be able to learn a little bit more about it on our Voyager episode if you're interested in that. Now, about the discoveries, Voyager 2 was directed into a path of about 4,950 kilometers above the North Pole of Neptune. 5 hours after Voyager 2 made its closest approach to Neptune, it performed a close flyby of Triton. As it was mentioned before, it is the larger of Neptune's 2 originally known moons, passing within about 40,000 kilometers, revealing the coldest known planetary body in the solar system and a nitrogen ice volcano on its surface. The moon is bigger than Pluto, and the only one of the solar system's large moons with a retrograde orbit, meaning it circles Neptune in the opposite direction from the planet's spin. And Voyager 2 also discovered that Triton is scattered with relatively young surface features, hosts active geysers, and even shows hints of a subsurface ocean. It has one of the more substantial atmospheres of the solar system moons, but it is significantly thinner than Earth's. Consisting of nitrogen, methane, and carbon monoxide, this atmosphere likely originated from volcanic activity. And besides Earth, Triton is only one of the 3 solar system bodies known to currently be volcanically active. Voyager 2 also discovered 4 previously unknown Neptunian rings, as it was mentioned before, as well as the 6 new moons, Despina, Galatia, Larissa, Proteus, Naiad, and Thalassa. And also, images reveal that details of the 3 major features in the planetary clouds, like the lesser dark spot, the great dark spot, and Scooter. And as it was also mentioned before, the great dark spot has actually since disappeared, and it is now theorized to have been a window of clear clouds, allowing us to see the methane cloud deck. Now, 40 years later, And scientists are still trying to send new missions to explore the boundaries of our solar system and get a little more than just a glimpse of Neptune and its moon system. For the moment, there are no official missions planned, but there are a lot of ideas in mind. After being considered a priority candidate to study objects that may hold an ocean beneath its surface, Triton is one of the main objectives of NASA's Triton spacecraft, which was one of the missions proposed in 2019 in order to study the outer planets with a focus on Neptune's largest moon. The mission would be planned to encounter the moon in 2038, taking an advantage of an efficient gravity assist alignment, which is an alignment made by Jupiter and Neptune that would enable the spacecraft to observe in full depth the mysteries that Triton holds in its surface, as well as its atmosphere. Triton's objectives would be to obtain a complete map of Triton's surface, as well as to study the thin atmosphere, sampling its ionosphere with a plasma spectrometer, and determine if there is indeed a subsurface ocean. Moreover, the icy volcanism present on Triton's surface, and specifically its plumes, would also be studied by the Triton mission. But for the moment, we'll still have to wait for this mission to be finally approved, funded, and launched. But we can still try to study Neptune and its wonders with the space-based telescopes, as well as telescopes on Earth, just like on our observatory public viewings and on our live viewings, in which sometimes when the weather allows it, we are able to see Neptune in all its blue glory. And well, now we are resuming back to live imaging, as a matter of fact, with Connor and Laura. Go ahead.
So we are looking at Deneb right now, and it looks pretty good right now.
Yeah, it looks really good. And Deneb is actually the 19th brightest star in the night sky. It's around 2.615 light years away from the sun.
Oh, well, does anyone know in which constellation is Deneb located?
Deneb is actually located in Cygnus, the Swan. And I believe it's part of the summer triangle as well. So the three stars, the three bright stars that you'll see in the summer, I believe it's one of those ones as well.
Indeed, it is. It's part of the summer triangle, which consists of Deneb, Vega, and Altair.
Well, it has an apparent magnitude of plus 1.25, and it is a star type of A2IA. So that's some astronomy facts right there.
Deneb's actually really hot. It's almost twice as hot as our sun. The average temperature is estimated around, I think, 8.5 Kelvin, which is actually really hot.
Even though we can see that it is very bright and luminous, we have to take into account that approximately Deneb is at 1,500 light years from Earth. So just take that in account when you're looking at its brightness and everything. So it's really bright, and it's really big as well.
Yeah, like mentioning about the surface temperature, it is actually 19 solar masses huger, and it's 203 times like in radius bigger. So no wonder it has a surface temperature of 8,525 kelvins. But what actually surprises me, it has a rotational velocity of 20 kilometers per second, not r. It's 20 kilometer per second. So that's really good for a huge star.
So right now the star may look a little fuzzy, but trust me, our team is amazing. It's because the sun is actually affecting the viewing. If it was really dark outside, it'll be much easier to see the star because of how bright it is. But because it is summer, we're gonna have really late nights. So we do apologize for that.
So for our next target, we are gonna be going towards Albiro.
And a cool thing about Albireo is actually that it's also part of the same constellation Cygnus, the same swan constellation.
Awesome. So I guess we are going towards Albiro, and it's a binary star. Awesome. Do we see that red spot there?
So that red spot is actually composed of two stars. As Arfa just mentioned, it is a double star.
So actually, Vega, Albiro, Altair, Deneb, and Cygnus, they are like under the same constellation, relatively close together. Like they are still light years away, but close together in the sky to locate. Okay, back to Matt. Thank you so much for the live viewing, guys.
Yes, again, thank you to Connor and Laura for letting us watch the sky, look at the sky a little bit, and well, thank you everyone as well for those very interesting facts that I actually didn't know. And well, everyone, you have been listening to the Alan I. Carswell Observatory's weekly Teletube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening were Arfa, Noah, Shannon, and myself, Matt, as well as Connor and Laura in the telescope, in the 1 meter, of course. Make sure to leave any comments or questions in the comment section of the video and talk to us in the chat right now, because we will be around for the next 20 minutes to answer your questions. All of our programs are free, but if you would like to make a donation or even buy one of our observatory astrophotography calendars, now at a 50% discount, you can see our website at observatory.info.yorku.ca. And you can always connect with us on Twitter with the handle @York Observatory, and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in. Clear skies and have a great night.